Hello everyone. My name is Andreas Börner. I am the Chief Innovation Officer of Smartstream, and in my role, I'm responsible for all the innovations that Smartstream is doing. I would love to be in person with you today, but due to the international situation, I'm presenting from Austria, in Vienna, from our innovation lab. Today, I will be presenting to you the latest innovations that we did. But first, let me shortly introduce Smartstream and the Innovation Lab. Right. So Smartstream is a global provider for financial services and financial software. Smartstream was founded more than 40 years ago. There are more than 2,000 customers. The Innovation Lab is located in Austria. We have mathematicians, data scientists, and senior software engineers that work together, and we want to outperform the state of the art. We work together with selected clients, and we do various AI use cases. And 2 use cases I want to present to you today. First of all, what drives us in Smartstream? So if you think about a navigation system and how easy it is to use, there's just a single field and you press start. And if you compare that to how we navigated 15 years ago using maps, which was very stressful, it was impossible while we were driving, and we made many mistakes. And the navigation system is not just a digitized version of the map, right? Because it gives me instructions while I'm driving, so I can drive and navigate. And there's a lot of extra information, like the time of arrival, traffic conditions, or if there are any construction sites. In the financial services industry, we are still at the very beginning to start such a process and have those applications. And this is what motivates us in Smartstream. We want to make financial services as simple as possible. We want to have financial service applications which also have just an input field and a button and provide lots of extra services. So our global strategy is, if you look at Smartstream's portfolio, we have a lot of applications out there with our clients. And those applications contain data. In that data, there are workflows, there are decisions our clients are taking, there's risk assessment, and so on. And everybody says these days, data is gold. But of course, it's only gold if somebody is using it. So our mission is to use that big data, those standardized workflows, and all the knowledge that people did to that data, and convert it into an AI model. So the lab's strategy really is to help customers transform their data into knowledge to optimize their business. I want to show you 2 examples, but first of all, let me explain a bit what reconciliation is, that everybody understands the complexity and also the use case. So reconciliation is a data problem. And it's a bit similar with what I show on the screen with cards. You hold your cards, which is typically your financial data, your structured customer data, static data. And on the other side, you need to sync with different data you got from clients, from brokers, from other banks, from other companies. Typically, those 2 data sets are in different structures, completely unsorted, and they contain data problems. So it's not as simple as a card game. It sounds a bit trivial in the beginning, but also there are millions and millions of records that we reconcile every day. Yeah, and there are many business scenarios in there. There is where one data record fits many other data records, or where there are reversals where somebody paid something and now wants to get the money back. Reconciliation is a big topic for any organization out there. It's a synchronization problem with lots of data, with complex data, complex workflows. When we speak about AI in reconciliation, our target is to make that complex workflow as simple as possible, and as quick as possible, and as safe as possible. We have implemented an AI engine, which is called Lightning AI, because it's really fast. That AI system understands data structure, data content, and it can correlate two data sets. And it's really like that navigation system I showed in the beginning. So the use case is that the user uploads files, 2 files, 3 files, or more files, any structure, any content. The AI system identifies the structure, identifies the correlation between these two data sets, and automatically computes what matches and where are things that don't match. Because in the end, a user really wants to understand where the problems are to work on those. And that saves a lot of time and a lot of effort. So let me demonstrate you that in a quick video. I have recorded a quick video, and I'm going to play that for you. So what you see here is our reconciliation software, Smartstream Air, where a user uploads 2 files of different formats, one from the payment gateway and one from an internal system. And you see by just one click, what that system does is it runs an AI process. It correlates the data, it identifies which fields belong to each other, and it automatically gives the match rates to a user. Here, we could match automatically 95% after a few seconds, and there are only 2 outstanding records where a user has to look at them and resolve them. It can be such a simple example, but it also can be a big data set with millions of records. That AI system is very quick, highly efficient to onboard data and to quickly bring back results. Another topic in the financial industry is observational learning, and it's a great example to also explain another AI component that we have. With Lightning AI that I just showed you, we found all data patterns. So we understood what is in the data, right? What data patterns? How does the data look like? Observational learning on top of that goes one step further. We understand the business knowledge of how people use the data. We understand the how the data is being used, how everyday's business is run. We observe how a user communicates with the data. Again, a bit of a background. Observational learning comes from psychology, and it's about how do we best teach and learn. You see here a picture of a child, and it's tying laces. Can you imagine to explain to a child how to tie laces without showing that kid how to do it? You have to say, take the left, take the right, turn it. It's very complicated. And I'm very, very sure that the kid will not understand what you tell. Alternatively, you show how to tie laces, and you will see that children will pick up quite quickly something when it's being shown to them, because observing things is a very efficient way for humans to train and also to learn. And that's not only true for children. So also when we have any hobbies like cooking or doing something else, we typically these days go on YouTube and we search for that topic and we listen and we observe how other people do those hobbies, because it's a very, very efficient way to learn. Yeah. So observational learning is good to train, but also to understand. And we use the same concept in the financial services industry, which I will show you in a second. So again, that example, right? I have my cards and I need to compare them to the unsorted cards. Wouldn't it be great if somebody helps me sorting those cards? So for example, I have my financial records and I need to compare them to another financial data set. So let's start with training the AI, right? I take my king and pick the king from the unsorted cards and put them aside. Next, I take the 9. I don't know if you have seen the 9 yet, but there are 2 9s in that data set. So I take the 2 9s of the unsorted data set, put them together and put them aside. If I do that, the AI system will observe and will try to understand what I'm doing. Is it the number on the card? Is it the color of the card? Is it one-to-many or one-to-one? So it will try to observe and understand what I'm doing with that data. Yeah. So now, when the AI has observed it and got some confidence, wouldn't it be great if I take that 7 and it would take automatically from the unsorted cards all 7s, and also it will explain me why it took those 7s. Again, it could be color, could be the number. And with that, I also want to have a confidence, how confident the AI is. I would say 70%. I'm confident with the cards I presented to you are the right cards. And look at that efficiency gain that we have with that. Because when I touch a card from my financial records, it will search through all the other cards and it will bring those cards which are like my card, which belong to my card, close to my card. So it will bring all that efficiency that I don't need to search. I don't need to compare. I really just compare suggested cards. All right. Again, I show you a small video. This is affinity learning in reconciliations again. And what we see here is a trained model. So a user has already done some clicks in that system to train the model. And the model you can see at the top is quite confident. And now I want to show you, if the model is confident, how affinity suggests records to a user. Okay. So let me play that for you. A user selects a record and you can see immediately that another record was suggested by the system. There are 3 things: date, amount, and reference, that have been the matching criteria. And when a user hovers over them, you can see an explanation. Also, what the AI system gives is a confidence value. So it will tell the user how confident it is that this record belonged to the other records. Yeah. And with that, users can match super efficiently by just clicking records, getting the suggestion, and then selecting other records. Now we come to a real use case, because the ad hoc scenario that I just showed you, where you select one record and then you get suggestions of other records, is still a very manual use case, although it brings a lot of efficiency. But the real use case for large banks is if we automate that. So that use case I'm showing you now is a fully automated version of Affinity, where a very large international bank worked together with us. They have quite a big reconciliation department. And with Affinity, we could optimize the business to be 20% more effective in the end. So what you see here is a graphic that shows in blue what was automatically matched by their reconciliation system so far. Yellow is what they matched every day, and gray is what they couldn't match because the other records only arrive on the next day. So in fact, the yellow part is the daily work they need to do. What we did is we trained Affinity on that yellow part. You can see that here. And then every day we provided into Affinity the yellow and the gray part to give us back what an AI system would suggest as automatic matches. Maybe it's also useful to tell you that the automation rate could not get higher in that example, because the rules you would have to set up for that system to achieve higher matching rates and become more efficient would have cost a lot of money and a lot of efforts. With Affinity, that comes automatically. I show you that. So we run Affinity, and this is actually the result of Affinity. So you can see from the originally blue areas, now Affinity can match another 2/3, which is a fantastic outcome. Yeah. So in the end, what we can see is that the remaining work for that bank was only that small orange piece. And if you compare how it was before and how it was after, I think that is a fantastic result. Again, Affinity is a standard product of Smartstream. It doesn't need a lot of customizations. It's not a data scientist that is working for weeks and months. It's a standard component that observes the data and then understands how the matching patterns work and suggests to users matches, or it automatically matches. Yeah, so this is another reconciliation use case with a lot of data. All right, I'm coming to an end. Let me give you a summary of what I've shown you today. I've shown you some innovation highlights that we do in Smartstream. First of all is this data fingerprint that we are doing with AI and machine learning to understand what is in the data. It's called Lightning AI, and it's a highly efficient AI component. With that, we can do this self-supervised learning, where when we present two data sets, we can automatically match those data sets and correlate those data sets, which reduces the time when mapping an ETL was needed, where it took hours and hours. We can reduce that to seconds. It's a component that really brings a lot of efficiency to business. And the last thing I showed was observational learning, and it's called Affinity AI, that component, which observes how a user matches something, and once it feels confident, it can do that process automatically, and it can help users to really get more efficiency and get a better quality for their systems. So much for listening. Thank you.